All right, guys, we're going to create a prototype that demonstrates the compression of molecules in a piston chamber. All right. So to give you kind of a preview of what we're going to do here, I'm going to show you this is the end product of what we're doing. We're going to create the piston is the purple mechanism in the middle that we're going to control with using our up and down arrows on our keyboard. And the frame of the piston cylinder is a different color, and the molecules are programmed to bounce off different colors. So to create the molecules, the sprites of the molecules, let's turn that on again. Sprites of the molecules, and then you can see the count collisions per second. Either molecules touching the side, top, or bottom, and each bounce is considered a collision. Alright, so we're going to go into preview some of the programming. So we got two sprites or two objects that we're creating. One's going to be a molecule, the other one's going to be the piston. So here's the code for the piston, and you can see that in the center of the screen I've got the when I click the flag, I'm going to create a clone of myself 100 times, and basically that one molecule is going to multiply 100 times and fill up the volume of the piston cylinder. The top, when I start to clone myself, that's the top left-hand side of the screen, is going to be the code that creates the directions for the molecule to go to the center of the screen and show the molecule at the center of the screen. Then the forever loop is going to control if touching the wall, bounce. So it's going to basically say if it touches the wall, it's got to bounce off the wall, and it's going to move around the piston cylinder 10 steps at a time to create that appearance of motion. All right, and so I'm going to create two my blocks. It's called my blocks, and basically I'm going to tell the block of code on the left-hand side has two if-then loops, if-then statements, and it's basically going to say if the molecule is touching the top or bottom of the piston cylinder, which is a certain color, then it's going to turn around, do a 90-degree turn, and if not, it's going to move around the piston cylinder 5 steps at a time. And the second if-then statement on the left-hand side there shows if it touches the side walls, left or right, it's going to turn around 0 degrees, head back, and move around the piston cylinder 5 steps at a time. The my block in the center of the screen is if escaped, replace, and delete. So the piston goes up and down in the cylinder on the y-axis, and depending on where the piston is, it could be all the way down or all the way up. If a molecule escapes the piston cylinder and gets above the piston, this code detects that molecule and deletes it. So if your piston has doesn't stretch all the way across the screen and allows for molecules to get around it, then this code will catch those molecules so that you don't have molecules above and below the piston. And let's put on the other one real quick. Not that one. Molecule. Now looking at the top of this page. This is page 1 of 2. So I'm creating a clone of myself, and to create the clone, you create the clone, and then you have to hide that clone so that you don't have one solid piston cylinder filled with molecules. It shows up, moves around, disappears, and then when another one's created. Alright, so we're going to get into the video here real quick. That's just a preview of our code there. Actually, one more preview here. This is the code for the piston. Pretty straightforward. Code on the left, up arrow changes the Y position of the piston, going +5, and down arrow is change the location of the piston in the negative direction, going 5 steps at a time. The code with the green check flag is 2 variables I created called bounce and collision per second. So a bounce is a collision, and that's counted as the molecules hitting the wall or hitting the cylinder or the floor or ceiling. And we're trying to create an illustration of what happens when you push the cylinder up and down and you create compressed and decompressed gas. And the reason this is important to understand this concept is because petroleum engineers will use this technology to determine the strength of pipes around corners, and as compression on gas or liquid molecules increases, you're going to get the strength of the pipes that those liquids or gas are in is going to be tested. Okay, so this is kind of a entry-level understanding to how petroleum engineers will take a study of gas and liquid molecules and how they act under pressure. Alright, let's open up the video here real quick. Let's get rid of that, and here we go. Alright, so here's the video I created a couple days ago, and I'm just going to summarize what you're seeing here. So I'm going to pick the sprite or the molecule. So the ball is basically a molecule, and you don't want huge molecules, so I'm going to reduce the size of that molecule, and you're just creating one molecule because the code's going to actually multiply that into hundreds. Alright, so then I'm going to duplicate that molecule or that sprite, and I'm going to create the piston, which is basically a level ceiling, and I'm going to just pick a color at random. I'm going to color it red, and you have to make sure it stretches all the way across the screen, because if not, molecules will go around it. Then you'll end up with molecules on the top of the piston. Alright, so put the piston in the center of the screen. I'm stretching it across both sides, left and right. So on the working plane is on the left, and the program pane is on the right. So when I refer to those two panes, you'll know what I'm talking about. Alright, so this is the handle. It's really not a functional handle, it's just there to illustrate that this is a piston, and further on in the video I'm going to actually change the color of that red to purple, because it's important that the top and bottom are one color and the left and right sides are a different color. So I'm going to program the molecules to bounce 90 degrees off the purple, which is going to be the top and bottom, and 0 degrees, bounce off 0 degrees off the left and right walls, so that it's always bouncing toward the center of the piston cylinder. Alright, so I'm creating the bottom. We're going to make sure the bottom stretches all the way left and right, all the way across the screen. Otherwise, you're going to get molecules that escape the piston cylinder and go below. And then I'm going to create the sides. Oh, and by the way, this is you're going to select. We're not creating a sprite or a character. We're creating the backdrop or backstage. So the backstage basically is the frame of the piston, and it's going to contain the molecules. And so just one recommendation: when you try to create this yourself on your computer, it's better if you take screenshots of this tutorial, print them out, because if you do a split screen where you have my tutorial on one side and the Scratch website on the other, where you're creating this prototype, it's hard to see the menu text because it gets so small, and so you're kind of like, it'll slow you down. So it's better just to have a printout. That way you can have you can take up this entire screen with your Scratch website. Alright, so what I'm creating here, let me get my notes. Talking about notes, let's catch up to where I'm at. We are on the piston. We've selected the piston, and we are programming the piston, and we are creating two variables called bounce and collisions per second. So it's important to know that number, because we want to know what are the collisions per second as we lower the piston tighter and tighter onto the molecules. So here we have to make sure that collisions per second equal bounce, because a bounce is a collision. Alright, so we're going to make sure we set bounce and collisions per second to 0, so that we don't add to our score or our count from previous trial runs. Alright, so then we are going to, I think, in the video I created yesterday that we're watching here, I may have made a mistake, and I think I fixed it. I'm not sure if I did or not, but alright, so it's important to insert a wait block after your initial count, so that the program can kind of separate the two sets of commands. And so you put the set, bounce, and collision per second in the forever loop, because you want the molecules to count forever inside, as long as you have the green flag clicked. Alright, so right now we're creating the input commands from the keyboard. So when you press the up arrow, it's going to change the Y value by +5, and when you click the down arrow, it's going to change the Y value by -5, or -5 steps. So the thing about this tutorial, you're able to pause the tutorial, rewind if you have to, take screenshots, print those screenshots out. And you can see as I press the up and down arrow, the piston on the right is going to move up and down. So now that we've got the piston programmed 100%, we are going to well, we've taken care of the easiest part, and we're going to save the hardest part for last. And what am I doing here? Let's see. All right, now I'm going to switch to the molecule, and we have nothing programmed for the molecule yet. So this is going to take about 10-15 minutes, and we're going to start off with, let's see. So when you want to take that one molecule and turn it into 100, you have to use the clone feature, and you're going to clone myself and put that in a repeat loop 100 times, and you're going to put inside that repeat loop clone myself. Then you want to put on the outside of that repeat loop the hide command, so that you create the clone and you hide it so that it doesn't it remains in the shape of a ball instead of turns into like a snake and goes across your screen, kind of like we did last week. All right, so I've got the clone command set up. Now what I'm doing is telling the program when I start a clone what I want to do. Basically, I want to go to X, a random spot on the X-axis and a random spot on the Y-axis. So I want the molecules to fly around my piston chamber in a random direction on the X-axis and Y-axis. Alright, so let's see. So I put in a operator inside the motion command, and so I'm going to go pick random -200 to 200 on the X-axis, and then I'm going to go on the Y-axis. The molecule has to detect the piston because the piston is going to move along the Y-axis. So I'm going to have to make sure that the molecule understands that its piston chamber is going to shrink and expand according to the position of the piston. So we have to program the molecule to detect the piston. And let's see if I think I'm figuring out here. Okay, so I'm taking out a operator. So I'm going to pick random. And actually, I think what I need to do is, I think I'm going to fix this here in a second here. I need to put in a Y position of piston, so I'm going to have to put in, where am I going? I have to fix that. Oh, inside the motion, there's a command that I think in this situation it took me a while to find it, but it's down there at the bottom. Go one more up. So you can see that there it is, I think. There it is. Okay. So I'm going to drag that command up, and that is going to go in the first, zoom out. So that's going to go in the first oval on the operator. And then I'm going to pick the Y position of the piston, and then I'm going to go and put in another okay. Yeah, so I got to put that one in first. So I'm going to put that double oval, and I have to pick of, what was that at? So that's going to go there. Okay. Okay, I think I got it. All right, so it's going to pick random negative 140 to Y position of the piston, and so minus 10. So it's going to pick the Y position of the piston, and it's going to go 10 less steps under the piston. Okay, so that's what that command is doing. One of the most difficult, because it's basically what creates this autonomous program, to where if it cannot detect that piston and the changing positions of the piston, it's not going to work, because you're not going to be able to adjust your piston, and the molecules won't see it, so it'll fly right through it. All right, so then we are point in direction, pick random, negative 180 to positive 180. And what that command is doing right there that you're seeing is, once it detects the piston, it's going to change 180 degrees in the other, either left or right, and go in that direction. And then it's going to show that value. And then below that, we're going to put a forever loop. And inside that loop, I'm going to put some blocks called my blocks that I got to create. I'm not sure if I've already created them yet in this video, but let's see here. So the first thing I got to do is I got to set the volume. The molecule volume has got to be at 100%. And so I'm going to put that in there, and I'm going to have to create a variable at a later time called molecule volume. And so we'll revisit this part of the command here in a few minutes. Then my next task is to put in that forever loop. The clone has to know if it's touching the wall, it's got to bounce. And if it escapes, then meaning it's got above the piston, then it's got to replace and delete. So if it escapes above, and you'll see the video here in a little minute, that the molecules will actually disappear when they get above the piston. So that's what that command does. All right, so to create a my block, you're going to go in and you're going to go select the first box, which is add an input. Type in the name of your variable, which is this. In this case, it's if touching wall, bounce. And then I'm going to create that. I have to define it. But before I do, I'm going to have to create another my block. Let's see. What is it waiting for here? So I got to create another one, and that's going to be it's like the same thing. Add an input block, and we're going to put in if escaped, replace, and delete. And we're going to create some code for that. And once we create this code, we've got the piston design, we've got the molecule, which is basically just a single ball. And we're going to finish this code up here in about 5 minutes. You're going to see how this works. It is a challenge. I think there's one block that I missed above there in that forever loop, but I'm going to come back and fix that here in a second. Alright, so now I got to create the code for if touching wall bounce. Let me get my notes. If touching wall bounce. Alright, okay. So I'm going to put a if then below that, and we are going to, if it's, so we're going to say, okay, if it's bouncing off the top or bottom, this first one's going to be, if it's bouncing off the top, it's going to turn 90 degrees. We're going to subtract the direction, and we're going to multiply that by 2 degrees in the opposite direction. So that's what we're doing right there. And we're going to put in a repeat loop below there, and we're going to repeat this until it's not. And if it's not, we're going to repeat. If we're not touching that color, we're going to repeat the step of, basically we're going to move 5 steps around the piston chamber until we actually touch that color. Alright, so here's where I came across the problem that I discovered that I created 2 different colors for top and bottom. And I'm going to have to troubleshoot and figure out how to fix that. And that's what you're watching right now. Is I'm going into the first I'm going into the piston, and I'm going to try to figure out, should I make the bottom red or should I make the top purple? And so I was just kind of goofing around here, and I decided to make the top purple, so that if the ball bounces off, detects purple, it's going to bounce off the purple and go in the opposite direction. So as you're watching me build this, I'm trying to get ahead of the notes here. But so if you're having a problem with using the color picker and cloning that color for your other object, you can actually look at the values and duplicate the values by opening up the color box, like I've got that open now. But in my case, I actually just kind of navigated around the 2 different objects until I finally figured out that I just can create the purple piston, which is going to be here in a couple seconds, and you'll see it turn purple. There it is. So I'm going to get that color there. I'm going to select the handle of the piston and just select that color and fill it in with the sealing of the piston here in a couple seconds. Alright, so after I get past this point, and I'm taking my time fixing this, but that's why it's kind of important to read ahead in your notes so that you don't make these kind of errors. So to fill that, you just pick that paint bucket to the left hand side there, and eventually, there it is. Okay, finally, got it fixed. Alright, so now my top and bottom are purple, my left and right are black. Now I can actually code this back into the code. Make sure you select the bottom right hand corner, that you're going to select the sprite or object you're trying to code. So back on, now I'm going to pick on the color, and I'm going to pick the paint bucket, and I'm going to hover over there and pick the color, and that auto-populates that color into that oval. Now I can say, if touching purple, then I'm going to turn 90 degrees and go in the opposite direction. So I'm in events, and I think I should actually be in motion. Let me go to motion. Oh. So the block that I just put in there, that is change the bounce by 1, and what that's doing is it's taking the molecule and it's changing the score tally. So it's basically run the score. So every time it bounces or collides with the side, it's going to count by 1. All right, that block that I just put in there, that is the turn block. So when it detects purple, it's going to turn. Purple is going to be the top and bottom. So when it detects purple, it's going to turn. Now I got to put in a operator. I'm going to multiply. First, I'm going to subtract direction from 90. So I'm going to type in 90, and then I'm going to find direction, which is under motion. So I'm going to take direction, and I'm going to subtract 90 degrees, and then multiply that by 2 degrees, which is basically going to say, okay, I'm going to turn around 90 degrees from the purple and go in the opposite direction 2 degrees. So that creates a completely random direction of the flight of the molecule. All right, so below that, I'm going to create a repeat until loop. That's going to be under the control tab, the control category with the commands there. And I think I found it. There it is. Okay, so I'm going to put in a repeat until. Now in that angled hole there, I'm going to put a operator command, which is the green category of commands of program blocks. So I'm going to put in repeat until it's not touching. So I'm going to if repeat until, so I've got that, until it's not touching. So I'm going to have to put in a there's that operator command, not, and then I'm going to put in touching, which is under senses or sensing. Then it's going to be touching color purple. So somewhere in there is a I think it's up there. There it is. So that's going to go there. So if it's not touching purple, it's going to be flying around the piston chamber 5 steps at a time. All right, so I took the color picker and I went over there and I picked the color of the bottom. Put that in the auto-populate that into the thing, and now I'm going to say, okay, if it's not, it's going to be taking 5 steps. So it's going to move 5 steps around the piston chamber until it actually collides into something else. All right, we're about 5 to 6 minutes before we've got this completed. It is a challenge. This is a challenging program, definitely. All right, so this the second if then statement, if then loop, is going to be if it's touching the left or right walls of the piston chamber. And so we took the color picker, we went out there and got the numerical value of the color of the walls and put that into the command. So if it detects that color, it's going to change the bounce by 1. So we're going to change the score by 1, or the collision by 1. And it's going to add that up to its previous score. Then we are going to, below that, we're going to put in the turn command, and we're going to turn 0 degrees this time. And so we're truly going to have the molecules flying in different directions. So then until, so we, I think I may have the wrong command in there, but I think I'm going to fix that here in a second. What I need to put in there is a repeat until, the same kind of loop that I put in the top. And they have this, so let's build on the turn command first, and I'm going to put that out there. Put in my subtract direction from 0. So I'm going to put 0 in there, and I'll put the direction is under the sensing, and that's going to be, or no, under motion, I'm sorry. Under motion, you're going to find direction. So pull the direction into that circle, and then we're going to multiply that by 2 degrees. Type in your 2 there. And then below that, we're going to put in the, if it's not touching, and I do have a mistake there that I'm going to fix here in a minute, but this is a video that I created yesterday, so I'm going to have to wait until I fix it. Alright, so basically I'm going to use the color picker to pick the color of the sides of the left and right walls, and then I'm going to put in a move 5 steps. Move 5 steps if I'm not touching the wall. So I'm going to move around until it's basically telling the molecule to move around until I collide with the wall. Alright, so there's a mistake I'm going to fix when I come back and fix it. But now we're going to move on to the, we're going to tell the molecules to, if you escape, I want you to replace and delete. That's the my block that I created, and I'm going to put a if then below there. If Y position is greater than the Y position of the piston plus 10, then I'm going to create a clone of myself, and I'm going to delete that clone. Okay, so I'm going to, I got my operator in there, so I'm going to say, okay, Y position. I have to find the Y position. Oh, I think this is where I got. Actually, what I'm going to do is I'm going to copy and paste a previous command that I created above that. Because at this point in the video, I forgot how I created that Y position of the pellet of the piston, and let's see in the video here what I did. All right, so while I'm trying to figure that out, I'm going to show you the here's the end product, and you can see that as the pistons, there's the molecules moving around. As the piston moves down, you'll see that some of the molecules escape and they get above the piston. And I'm going to push it further down. See the ones going up, and they, as soon as they know that they're above the piston, or their Y value is above the piston, it basically tells them to disappear. And that is what we're trying to create here. And I think I'm almost there. All right, so while I'm trying to catch up in the video, here's a picture of what I'm trying to create. You can see that I'm going to, actually that's the piston. All right, so okay, I found it. All right, so here's the Y position. I just Control C, Control V, Control C copy, Control V paste. I'm just going to take that chunk of code that I've already got created, and I'm going to drag it down to the if escaped delete function. Plug that in there. Now I have to say the first oval circle. I'm going to have to put in the Y position block. And that's under motion. So I'm going to put that in there. And so the Y position is greater than the Y position of the piston. I think I have to put in one more command because I've got to add 10 to that because I want the molecule to detect this 10 steps before the piston. So I think I have to take that back out and put an operator in. So if you run out of room, like I've run out of room here, you can always zoom out. That gives you the ability to kind of spread things out a little bit because we're getting kind of cramped in that small window there. So I think I caught on to my mistake here. Not really a mistake, I just left something out. So I got to go down to the operator, pick up a block. I think I figured it out here. Okay, where are we at? There we are. All right. So I got to pull in the block that is the two blank. On the top one there, you see it says plus. I need to pull that down and put this other one inside that so that I can add 10 to that. And let's see how quickly I figure that out here. Right, so that's going to come out. Got it. Okay, that one's going to go in there. All right, let's take our time here. All right, so that's going to go in that one. Got it. It took me a few seconds, but okay, so that one's going to go in there, and I'm going to type in plus 10 on that last spot there. So that's going to delete my clones if they get above my piston. Now I have to put in my last steps on there is create clone of myself and delete this clone. Okay. All right, now there is one mistake I got to fix, and I think at this point I detect I gotta turn my updates off. All right, so I'm going to test it out. Let's see what happens. Now I see that here's the point where I have to troubleshoot. So I create my code. It's not acting the way I want it to act because the molecules are not moving around. The piston's going up and down, as you can see. That's working fine, so there's nothing wrong with that code. So the reason the molecules are appearing the way they appear is because I'm missing a piece of code, and let's see if I can catch on to that quick enough. All right, so it's bound to happen when you create these programs in Scratch. Part of the learning process is to find out why things don't act the way you want them to act, and that's just your trial and error is the best way to learn. And in this case, it takes me a few minutes to figure out that I am missing a move block in the upper left hand code there underneath the my blocks that I created. So as soon as I put that piece of code in there, that's going to fix the motion of the molecules. But during this process, I found that I had another problem. I think I pointed that out a few minutes ago, that I had the wrong loop block at the bottom of the if touching while bounce command definition. So first, let's see if we all right, so we got to switch back. I think at this point I'm on to it. So one thing, if you want to push the flag and start your program, you can kind of see it'll highlight what's being executed while you push the up and down arrows, and you can kind of see and kind of zero in on your mistake. And I'm not sure if this is the point in the video that I find the mistake. We shall see here. So it is going to be a motion block that I got to pull into that right there. I think I found it. Got it. So I got that pulled in. Bingo. I'm going to push the thing, and there goes the molecules flying in all different directions, and everything's fixed. So we're 95% done with the prototype. And now we're going to figure out why our collisions per second is not being counted. And so that is a problem with a weight block. So we're going to put in, first we got to make collisions per second equal to bounce. There we go. And there, we have to put in a weight block. So as you can see, the collisions per second count is just going 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So what we did to fix that is we put in a weight block, and it slows down the collection of those collisions, and then you get the code is able to execute properly. And you can see that as we push down on the arrow, the down arrow on your keyboard, the piston comes down, and the molecules react to less space. And so, if I didn't mention this before, I'll mention it now. This is basically a prototype to show engineers how gas molecules and fluid molecules react in pipelines. Petroleum engineers are going to use this information to see how the shear strength of pipe corners, gas molecules, liquid molecules going around corners in pipes, how that's going to create pressure, friction, and heat, and determine the durability of that particular area of pipe that is going to take a large need for durability. So this is a simple tool, but it's something that can give you a picture in your mind of how something more complex could be used in an industrial setting that an engineer would use. And you can see as the piston goes up and down, you get the increased and decreased molecules per second. Of course, the higher molecules per second colliding with the side of the pipe, it's obviously going to create heat. It's going to cause stress on bolts and connections, and this is useful information for engineers to know. All right, so summarize real quick. I'm going to throw up the code just to summarize that real quick. We're finished. We got it to work. Once again, this is the code. You know, if you're going to create code, you got to make sure that you're paying attention to what you have selected. So if I want the molecule code, I have to make sure throughout going back and forth the screens, from screen to screen, you got to make sure that you reselect the molecule code, or you're going to be creating code for the wrong object, and you can end up having code that's meant for the molecule on the piston page instead of where it needs to be on the molecule page. So you can see this is the command in the middle is the one that creates the repeat appearance of the molecules 100 times. That's the ghost, or the ghost clone command. And then the other codes, upper left hand corner, this is creating the flight of the molecule around the piston chamber, random, so it's not just all the molecules are going in the same direction, it's picking random positions. And here's my other half of my code. This is my blocks that I created, and that is if it's detecting the top or bottom, it's going to go a 90, and if it detects the left or right, it's going to go 0 degrees and toward the center of the piston chamber. And then this one right here is if it gets above the Y value of the piston, it's going to delete itself. And then this is the code for the piston. Pretty much straightforward. It's basically input on your up and down arrow keys. And this is also going to define the collisions per second is equal to bounce. And then it sets bounce and collisions per second to 0 at the very beginning of when you initiate the code. And let's see, I think I showed all of the code. So you've seen the code, you've seen the video, you saw the final product. Once again, the final product, this is it. And it's a fun project, and there's a lot of lessons you can take out of this. Concepts are pretty cool to apply to more advanced programs, and you know that these concepts that we're learning here in this prototype are actually used in the industry, so it has a very relevant application. So this is a fun project. Have fun building it. Remember, it's easier to print out screenshots and have your Scratch program full screen, because you know I've tried to do side by side split screen, and it's tough to do it that way. But a lot of fun, and I'll see you guys in the next video.